Hello everyone, and welcome to the linked list nth to last node solution. Okay, your problem statement was to write a function that takes a head node and an integer value n, and then returns the nth to last node in the linked list. So for example, if you were given a class of node that looked something like this, as we've seen before, and you were creating a singly linked list, A, B, C, D, E, with values 1, 2, 3, 4, 5, and then you assigned it like this, so it's all in order. Then your function, taking in a n value and the head node, would then return that nth to last node. In this case, 2, which means second to last, and that would return the node D with a value of 4, so if we went ahead and checked that out, there it is. Alright, so now let's go over the solution to this before we actually dive into this code below. The solution goes a little something like this. Imagine you have a bunch of nodes and a block which is n nodes wide. We could walk this block all the way down the list, and once the front of the block reached the end, then the other end of the block would actually be at the nth node. So to implement this block, we would just have to have two pointers, a left and right pair of pointers. Again, you have a bunch of nodes in basically a straight line. We're not worrying about cycles here. And then you have a block, which is n nodes wide, which is going to be dictated by this input argument. So then you keep moving or walking down this block, which is n nodes wide, all the way until it reaches the end, meaning that the other end of the block would be at the nth node. And we're going to implement this block as just two pointers, a left and right pair of pointers. So we're going to mark out the steps we need to take. We walk one pointer n nodes from the head, and that's going to be the right point. Put the other pointer at the head, and this will be the left point. We walk or traverse through our linked list, and that block, as it's being walked, essentially both those pointers, towards the tail end of the linked list, one node at a time, we keep a distance n between them. So they start off separated, both pointers, essentially making that block of n nodes, and we keep moving them one node at a time in sync together. And once that right point has hit the tail, given that they were moving in sync, we know that the left point is at the target. Okay, let's go ahead and implement this so we make sure it's really clear. First thing I'm going to go ahead and do, say DEF, and we'll just say nth to last node. We take in that n value and then that head node. Then I'm going to make two variables, that left pointer and that right pointer. And these are going to define that, essentially, that block that's moving along our linked list. So I have a right underscore pointer as well. That starts off as that head node. So we are going to set the right pointer at n nodes away from the head. So I'm going to say for I in, I'll say x range. For using Python 3, that's just range. Difference between them is one's a generator, one's not. We can check for edge case in case we don't have enough nodes. So we'll say if not right pointer dot next node. And this basically means that we just didn't have enough nodes. I'll raise an error. In this case, I'll actually just raise a lookup error. And I'll say error n is larger than the linked list. It's always good to think about edge cases as you're programming. Your interviewer will definitely be checking out for those and see how aware you are about edge cases. Again, they're not your primary concern, so you should always be coding stuff out, and a common strategy is to code out the basic solution and then think about edge cases verbally along with your interviewer. In this case, this one's a pretty obvious one, so I just put it in right now. Alright, so if we're not receiving an edge case and we do have enough nodes, I'll just say right pointer is equal to right pointer dot next node. Okay, essentially that block and the left and right pointer are now set up. The left one starts at the head, and the right pointer has now moved n nodes away from the head. And we're going to move that block, those two pairs of pointers, left pointer and right pointer, down the linked list. We're going to use a while loop to do this. I'm going to say while right underscore pointer dot next node, which essentially means while it hasn't reached the end, while it's not none, which is why I'm able just to do these if not right pointer next node, while right pointer next node. So I'm not putting any comparison operations because I know that this value is essentially going to be none eventually, meaning it's reached that tail. And that's why I'm able to not have to do any comparisons with that if and while statement. So I'm basically saying if not none or while, basically it actually still exists and is not none. So while that's still going on, we haven't reached the end yet. I'll say the left pointer is just equal to left pointer dot next node. And then I'll say right pointer is equal to right pointer dot next node. So that's just moving them along together in sync. And now we just return the left pointer because this is going to keep executing until you've reached the end. So once that's done finishing executing, we just say return left pointer. That's going to be at the nth to last node. Okay, that's all there is to it. So let's make sure we run it and it all works out. I'm going to go ahead and copy that test cell. And let's run this. And all test cases pass. Excellent. All right, let's go real quickly line by line and make sure we fully understand what's going on here. I'm trying to find the nth to last node in a linked list. And my basic strategy is going to have a left pointer at the head and then have a right pointer that starts off n nodes away from left. Essentially n nodes down the list. So we have a block of nodes between left and right. Then I'm going to keep moving them along together in sync with each other until the right pointer, that right end of that block, has reached the final node, meaning while this is actually still true in some fashion and it's not none. After all that, we've reached the last node with the right pointer, then we know that the left pointer is at the correct node. It's the nth to last node in that linked list. And that's all there is to it. Okay, go ahead and code this out yourself. Make sure you understand it. Make sure you understand the logic of those two pair of pointers moving down. This is a pretty common interview question when it comes to linked lists, and you should definitely know it. All right, thanks everyone, and I'll see you at the next lecture.